Hello, and welcome to Snax. Today's presentation is R squared versus R squared adjusted. It is my pleasure to introduce our speaker, Jonathan Ross. Mr. Ross is currently the Associate Director for MSAT for Upstream Drug Substance at Resolute Bio. He has over 6 years of experience in the biotech field, developing and characterizing processes for monoclonal antibody production. Mr. Ross received a Bachelor of Arts in Biology from Willamette University and is currently pursuing a Master's in Applied Statistics from Colorado State University. Mr. Ross also serves as the Member Engagement Manager of the CMC Statistics Community for AAPS. Mr. Ross, the floor is yours.
So today's Stat Snack will discuss how to interpret statistical measures of model fit and the difference between the measures R squared and R squared adjusted. By the end of this video, I hope you have a better understanding of the meanings of R squared and R squared adjusted and their differences. The basics. Both R squared and R squared adjusted explain the proportion of variation explained in a statistical model. R squared adjusted, however, penalizes this value the more predictors that are added into the model. With more predictors added into a model, the model could be overfitting the data at hand and may not be useful for predicting new cases. R squared will always be a number between 0 and 1, and R squared adjusted will always be less than R squared. The extreme examples are shown here. The graph on the left is an example of when R squared is equal to 0, and the graph on the right is when an example is when R squared is equal to 1. Note when R squared equals 1, all the points fall on the line. For reference, two terms will help one understand how R squared and R squared adjusted are calculated. Sums of squares residual, or SS-res, and sums of squares total, or SS-tot. SS-res is the unexplained variation in the model. To calculate SS-res, one adds up the squared distances from the actual data point to the fitted line. And to calculate SS-tot, one adds up the squared distances from the actual point to the mean. These two values are used to calculate R squared and R squared adjusted. Equations. The equations for R squared and R squared adjusted are shown here. The R squared calculation is fairly simple, as it will give you a proportion of the variation explained by the model by simply subtracting the amount of variation not explained by the model. Again, if all data points fall on the fitted line, R squared will be equal to 1. R squared adjusted is a similar calculation, however, multiplies the amount of unexplained variation by a penalty term. The more terms included in the model, the larger the penalty term becomes. Pitfalls of R squared and R squared adjusted. Although these values can be useful when evaluating a model, one needs to be careful because they do not tell the whole story. As shown in the picture, the 4 sets of data each have a model fit to them. All 4 models have the same intercept, slope, and R squared value. As you can see, the line does not explain each set of data equally. The R squared and R squared adjusted values are not an absolute test of linearity. In summary, when fitting models to data, it is useful to have metrics that explain how well the data align with the selected model. There are several metrics in literature that one can use, but 2 measures you've likely seen are R squared and R squared adjusted. Other measures include root mean square error, AIC, and BIC. Use these values to better understand the variation explained by the model. I hope this served as a useful introduction to understanding these 2 metrics. For more information, please see this book called Applied Regression and Analysis. Thank you to everyone who contributed to this video. And if you have any questions, please reach out.